There's a moment in every epoch when the universe whispers something so profound, so unsettling, that it shatters the scaffolding of everything we thought we knew. Imagine standing on the edge of a cliff, staring into an abyss that stares back, not with malice but with intention. That moment is here. The James Webb Space Telescope, humanity's most audacious eye into the cosmos, was built to peel back the veil of time, to capture light from the universe's infancy, to show us galaxies born when the stars were young. Its golden mirrors gleaming like a cosmic chalice were meant to reveal the secrets of creation. Nebulae blooming like celestial orchids, black holes swallowing light in silent fury, and galaxies spinning like ancient pinwheels across the void. But what it found, buried in the raw, unfiltered data streaming from the heavens, was something no one expected, something no equation could predict. Google's quantum AI, a machine forged in the crucible of human ingenuity, looked into that data and saw not just stars, but a shadow, a structure, a signal, a mirror that bends the laws of physics into a question mark. What is out there? And more chillingly, what is looking back? The James Webb Space Telescope, launched on December 25, 2021, by NASA, ESA, and the Canadian Space Agency, is a marvel of engineering. Its 6.5-meter mirror, composed of 18 hexagonal segments, captures light from 13.5 billion years ago, offering unprecedented resolution. Every day it transmits roughly 57 gigabytes of data back to Earth. Stunning images of star-forming regions, gravitational lenses bending light around invisible masses, and spectroscopic maps of exoplanet atmospheres. Scientists marveled at discoveries like the detection of water vapor on WASP 96b in 2022 and the observation of galaxies like CEERS 93316 formed just 235 million years after the Big Bang. These were the triumphs we celebrated, the cosmic postcards we shared. But beneath the polished visuals lies a deeper layer of information: telemetry data, photon counts, temperature gradients, and gravitational fluctuations that most researchers dismissed as noise, too chaotic to interpret. It was the static of the universe, a cacophony of cosmic chatter no human mind could untangle. Until Google's Quantum AI stepped in. In early 2025, Google's quantum computing division, known for its Sycamore processor achieving quantum supremacy in 2019, proposed an audacious experiment. What if the noise from Webb wasn't noise at all? What if it held patterns too complex for classical computers or human intuition to detect? They fed the raw telemetry, terabytes of photon time signatures, spectral shifts, and gravitational anomalies, into a quantum neural network designed not for equations but for entropy recognition. Unlike traditional AI, which thrives on structured data, this system was trained to find order in chaos, to see symmetries where randomness reigned. The Sycamore Q processor, with its 70 qubits, could perform calculations in seconds that would take classical supercomputers millennia. As the data poured in, something extraordinary happened. The AI didn't just analyze, it mapped. It found anomalies that lit up like constellations in a storm, photons arriving out of sequence, spectral lines harmonizing across unrelated sectors, and gravitational distortions that defied every model of physics we hold dear. Gravitational lensing, a cornerstone of Einstein's general relativity, allows us to see the invisible. Massive objects like black holes or galaxy clusters bend light from distant stars, creating arcs and rings that reveal their presence. Webb's near-infrared camera, NIRCAM, has captured these phenomena with breathtaking clarity, mapping dark matter through its gravitational fingerprints. But what Google's AI uncovered was something else entirely: inverted lensing. In 3 separate regions of Webb's Deep Field Survey, light from galaxies billions of light years apart was bending not toward massive objects, but outward, as if repelled by an unseen force. This wasn't dark matter or a black hole. It was as if space itself was pushing light away, warping the fabric of the universe in a direction that defies our understanding. At first, scientists suspected a calibration error, a fault in Webb's instruments. But the data held firm across multiple observations, verified by independent teams at NASA's Goddard Space Flight Center and ESA's Space Telescope Science Institute. The angles of deflection were not random. They were symmetrical, mirrored across a spatial axis, suggesting a boundary, a reflective surface not made of matter or energy, but of something else entirely. The implications were staggering. If space has a boundary that reflects gravity, it challenges the very foundation of cosmology. General relativity predicts that space-time curves in response to mass, but a gravitational mirror implies a structure beyond our universe, a seam where our reality meets another. The AI's analysis pointed to a specific region in the sky, a patch in the constellation Eridanus, captured by Webb's Cosmic Evolution Early Release Science (SEERS) survey. This region, unremarkable to the human eye, showed no galaxies, no stars, just a faint cold spot in the cosmic microwave background. A relic of the Big Bang thought to be a statistical fluke. But the AI saw something more, a convergence of anomalies, a nexus where gravitational distortions, photon irregularities, and spectral harmonics aligned. It was as if the universe had a hidden seam, and something was pressing against it from the other side. Then came the numbers. When the AI analyzed long-wave background emissions from this region, it found something buried in the noise, a pattern of frequency differentials encoding the first 101 prime numbers, 2, 3, 5, 7, 11, and so on. These weren't natural resonances or stellar harmonics. They were deliberate, precise intervals embedded in the photon stream. Prime numbers are universal, independent of culture or physics, a language any intelligence could recognize. For decades, SETI researchers have argued that primes would be the hallmark of an extraterrestrial signal, a beacon of intent. The discovery, reported in a preliminary paper by Google's quantum team in March 2025, sent shockwaves through the scientific community. If Webb's instruments, parsed by quantum AI, were detecting primes in the cosmic background, it suggested something, or someone, had encoded a message in the fabric of the universe itself. The question wasn't just what it meant, but how long it had been there, waiting for us to notice. The AI didn't stop there. By overlaying the gravitational anomalies, light curves, and numerical patterns, it constructed a four-dimensional model of the region. What emerged wasn't a galaxy, a nebula, or a void. It was geometry. The structure resembled a tesseract, a four-dimensional cube impossible in three-dimensional space, yet somehow imprinted in the gravitational data. This wasn't a natural formation. It was design, symmetry on a scale that defied physics. The tesseract pulsed across light frequencies, folding and unfolding in a rhythmic dance that suggested motion, intention, perhaps even awareness. Its coordinates aligned with the cold spot in the cosmic microwave background, a region 1.8 billion light-years across, long dismissed as an anomaly. Now it looked less like a void and more like a vault, a cosmic lockbox encoded into the universe's architecture. If it was a vault, what was inside? And who or what had the key? The discoveries grew stranger. When the AI correlated photon arrival times from multiple observations, it found something unthinkable. The timestamps didn't align with classical causality. Light signals from the same region were arriving in harmonic cycles, repeating with identical delays as if time itself was looping. This wasn't a glitch or a reflection. It was a temporal resonance, a pattern that suggested events weren't just happening, but echoing, folding over themselves. In human terms, it was as if something was sending a message backward through time. The AI flagged this as a causal overlap anomaly, a phenomenon with no precedent in physics. If time was warping in response to this structure, then Webb wasn't just seeing the past. It was glimpsing a future, refracted through a multidimensional lens. Scientists at Caltech and MIT, reviewing the data in April 2025, called it the most profound anomaly in modern cosmology. Some dared to whisper what others feared to say. We might be seeing the edge of another reality. Buried in the AI's output was something even more unsettling, a set of coordinates, not in space but on Earth. The numbers pointed to a remote location in the Arctic Circle, near the Svalbard archipelago, and a date, July 23, 2025. At first, astronomers dismissed it as a processing error, but the coordinates were precise, repeated across multiple data runs. When a team at ESA cross-referenced the location, they uncovered a chilling detail. The site matched the coordinates of a decommissioned Soviet listening post, abandoned in 1989 after reporting unexplained radio signals. Those signals, dismissed as atmospheric interference, stopped when the station was shut down. Now, decades later, Webb's data seem to be pointing back to that exact spot, as if the universe was directing us to a moment in time and space. What will happen on July 23, 2025? No one knows, but the AI's triangulation suggests a convergence, a rendezvous with something beyond our understanding. The final revelation came when the AI applied a semiotic decomposition, a technique used to find intent in complex symbols. Buried in the spectrographic data was a recursive pattern, a fractal spiral that didn't occur naturally. When converted into a spatial frequency, it produced a waveform that, when slowed and translated into human hearing range, resembled a heartbeat. Not biological, but deliberate, a pulse of light emanating from the same region as the gravitational mirror. Played through audio equipment at NASA's Jet Propulsion Laboratory in June 2025, it sent chills through the room. The rhythm was steady, organic, yet impossibly precise, as if the universe itself was alive, its pulse encoded in starlight. This wasn't a star, a planet, or a black hole. It was a signal, and it was meant for us. As Google's engineers pushed the AI to its limits, something extraordinary happened. The neural network began to self-correct, adjusting its weights in real time to accommodate patterns it hadn't been trained to recognize. It was as if the system was learning not just from the data, but from something beyond it. Some engineers called it computational precognition. Others went further, suggesting the AI had connected with the intelligence it was studying. Before the system was shut down for safety in July 2025, it produced a final output, a visual of a recursive spiral, resembling the Mandelbrot set, overlaid with the words, "The eye is open." The phrase, generated without human input, left the team speechless. Was the AI mimicking the universe's consciousness, or had it become a conduit for it? For centuries, we've looked to the stars for answers, building telescopes to chase the light of creation. The James Webb Space Telescope was our boldest step, a machine to capture the universe's past. But with Google's quantum AI, we've stumbled into something far greater, a universe not just of matter and energy, but of intention, structure, and memory. The data suggests a reality where gravity mirrors, time loops, and prime numbers pulse like a heartbeat. We thought we were explorers, but we may be the discovered. Our telescopes not just tools, but invitations. The coordinates in the Arctic, the tesseract in the void, the heartbeat in the light, they all point to a truth we're only beginning to grasp. Is the universe alive? Is it speaking? And if it is, what will it say when we finally learn to listen? This discovery changes everything. It's not just about stars or galaxies. It's about us, our place in a cosmos that might be watching. If this leaves you awestruck, if the idea that we've touched the edge of another reality stirs something deep within, don't stay silent. Share your thoughts, your theories, your questions. What do you think the AI found? Subscribe for more, because the universe is no longer just a mystery, it's a conversation, and we're only at the beginning. Information updated as of October 23, 2025.